Hello everyone. Chargers have become an integral part of our lives. We use them literally every day. And it often happens that at the most inopportune moment the charger stops working, does not charge the tablet, does not charge the phone. How do I find out what the reason is? In the charger or in the USB cord? In this video, I'll show you how to figure it out in just 1 minute. In addition, I will assemble a simple device that will be very useful when checking and testing a charger or USB cord. I will solder, as usual, with the help of volumetric mounting. By the way, I'm going to use this soldering iron today. Homemade soldering iron from a resistor. Here in this video you can see how to make such a soldering iron and what it is capable of. The link to this video will be in the description below this video. So, to find out why the charger does not work, you can use a multimeter. But it will be much faster, easier and more informative to use a USB tester, especially if it is a USB tester of the latest generation with many functions, for example, such as a USB tester from FNIRSI, and its model FNB58. A link to this very useful device will be in the description below this video. If you wish, you can also purchase such a model for yourself. What is this USB tester? Let's figure it out. This USB tester is for sale in such a high-quality branded box. The reverse side shows the main features of this device. The measured voltage is from 4 to 28 volts. The current strength is up to 7 amperes. Power up to 120 watts. Capacity up to 10,000 ampere-hours. Consumed electricity or power up to 10,000 watt-hours. The USB tester itself has a very solid appearance. Huge. As for a USB tester, 2-inch screen. Aluminum housing. There is a plastic insert on the back cover for reliable Bluetooth operation. And several connectors. This is the USB-A input. On the opposite side is the USB-A output. On this side there is a Type-C and micro USB input, as well as a Type-C output and a power delivery protocol switch. On the opposite side is a connector for connecting to a computer. This connector is needed in order to work through the program installed on the computer, as well as to install new firmware and, for example, to supply external power. Mode selection, indication and joystick. It shifts to the left, right and can also be pressed. And the back button. Now I will connect this USB tester to a charger that outputs 5 volts and a current of up to 2 amps. This USB tester has 4 main screens. On the first screen we see the main characteristics of the charger: voltage, current and power. Now the voltage is 5.16 volts, and the current and power are 0 because the load is not connected. If you connect the load, and in this case it will be a phone, then the indicators change immediately. The voltage remains about the same, but the current is already 1.1 amperes and the power consumption is 5.7 watts. If you press the joystick, these values stop. One more click, and the tracking goes on in real time. The temperature inside the case is also displayed on this screen. At the moment, 24.9 degrees. The second screen contains more information. The left side shows the indicators, the characteristics that we looked at on the first screen: voltage, current and power. Here the voltage of contacts D+ and D- is indicated a little lower. These are the contacts of the USB plug for data transfer. In the right part of the statistics, Energy statistics. This USB tester has 10 cells for recording data. Here it is indicated that now the record goes to the first cell. And the next screen is an oscillogram. When you shift and hold the joystick to the right or left side, you can change the time period of the sweep. 0.5 seconds. 1 second. When you shift to the left, the values decrease. When the joystick is briefly pressed, the values on the screen stop and they can be analyzed in more detail. And with a long press, we go to the oscillogram on the contacts D+ and D-. Now there is no data transfer via the USB cord, so there are no spikes on the graph. And this is an oscillogram on the plus pin. Well, this is a very useful addition in this USB tester. The next fourth screen consists of 4 sub-items. At the beginning, we see a warning that we need to be careful not to damage mobile devices with high voltage. There are several points here, and the first of them is the automatic detection of the protocol that the charger supports. Now I will connect the USB tester directly to the power supply. And after the beep, you can see the result of the check. In this case, this power supply. This charger supports only the simplest and most common protocol BC 1.2. 5 volts and a maximum of 1.5 amperes. The following items are power delivery, quick charge 2.0, 3.0, fast charging from Huawei, from Samsung, VOOC, Warp, SVOOC 1.0, 2.0. The USB tester works with all these protocols. It can configure, check and test them, which is very convenient. The next sub-item is statistics. The first point is energy statistics. This is what we watched on the second screen. All indicators are saved here, and you can view and analyze them if necessary. The second point is to check the battery. In this mode, you can check not only the capacity of a smartphone or phone, but also, for example, the capacity of a lithium-ion battery. To do this, you need to completely discharge it, and then connect it to a USB tester. During charging, this tester will determine the actual battery capacity. The next sub-item is toolbox, that is, a toolbox. There are several points here. The first of them, checking the resistance of the USB cable. As you can see, this connected USB cable has a certain resistance. But, obviously, it is within acceptable limits. The next point is to view the power delivery dialog. The next item is power delivery converter. Then check the electronic marking of the cable. Here we are talking about a powerful cable with a chip that is designed for fast charging. And the fourth sub-item is settings. There are quite a lot of settings here. I will name some of them. For example, adjusting the brightness of the screen, switching to sleep mode after 5 minutes. The temperature will be indicated in degrees Celsius. System language. The G sensor. That is, this USB tester automatically rotates the screen when the position changes. The Record tab. Here you can set the maximum recording time to 9 hours and, for example, set the minimum current below which the recording will be stopped. The Trigger tab. You can also set the maximum recording time. System. This is a factory reset. In the About tab, information about this device. As you can see, this USB tester has a lot of features and some of them an ordinary user probably won't even need. But for checking chargers and checking USB cords, this tester will be indispensable. In order for such a test to be the most objective and informative, a small addition is needed to this tester. It is an electronic or resistive load. You can buy it, or you can make it yourself. That's what I'm going to do now. And then with the help of this resistive load, we will check the charger and USB cords in more detail and accurately. You can download the diagram of this device in the Telegram group. The link to the group will be in the description below this video. Join us. The schematic diagram is very simple. It contains 4 absolutely identical lines, which consist of a load resistance and an LED to indicate switching on. When the switch is pressed, the resistance is connected to the contacts through which the supply voltage is supplied, and thereby creates a load for the power supply. Each chain consumes approximately 400 mA and 2 watts of power. I will solder 4 microswitches into one unit. Now I will solder a load resistance and an LED with a current limiting resistor to each microswitch. Two lines of this resistive load are ready. There are 2 more to do. There will be two USB connectors along the edges of this design. So, everything is ready. Now you can test this charger with a resistive load. Connect the USB tester. And now the resistive load. The voltage is 5.9 volts. The current strength is 420 milliamps. The power consumption is 2.1 watts, and the voltage has decreased slightly, but within acceptable limits. With a current strength of 0.83 amperes, the power consumption is 4.22 watts. The voltage remains approximately at the same level. The current is 1.5 amperes. The voltage does not decrease. The power is 7.75 watts. And this check indicates that this charger is quite functional. Now you can check the USB cord. 0.41 amperes. The voltage is almost 5 volts and the power consumption is 2 watts. 0.8 amperes. The voltage dropped to 4.9 volts. Almost 4 watts of power. The current strength is 1.45 amperes. The voltage dropped to 4.8 volts. Power 7 watts. As this check has shown, this USB cable has certain losses. There is a drawdown both in voltage and current strength, but in general it is suitable for charging mobile devices. Now I will check another USB cord and it will be seen what the problem may be. Micro USB connector. The voltage is 4.6 volts. Turn on one resistive load line. And the USB tester went out. Let's try again. The voltage is 4.7 volts. We turn on one shoulder of the load and the tester went out again. This check indicates that this USB cable is faulty. At idle, it outputs a voltage of 4.5 volts, but at the slightest load, the voltage disappears. That's how, with the help of this simple addition to this USB tester, with the help of such a resistive load, you can accurately and informatively check the charger and USB cords. This concludes this video. If you liked it, then click the subscribe button. Click and the bell icon next to this button to accurately receive notifications from my channel. I thank you for watching and bye.